Okay, let's draw a graph for a cot function. And this cot function is different from its parent function. It has a vertical shift. It has a phase shift. It also has a different amplitude other than 1. So here we go. First step, we'll calculate the period, which is easy. Use a parent period to divide the coefficient of x. Absolute value of coefficient x. And the second step, find the vertical shift and shift up by 1 unit. So we're originally on x, when y is equal to 0, will be shifted to y equal to 1. And remember the parent graph of a cot function. It is a decreasing function, but because of the a equal to -2, a is negative. And this graph, this function is an increasing function in each section between vertical asymptotes. I'm doing this voiceover over my lunchtime. That's why I have eating sound here. Now I'm calculating vertical asymptotes, so I can put those vertical asymptotes on a graph. I'll create those sections for our final graph. I use dotted line to represent the asymptotes. So right now I'm trying to put some coordinates on the graph, on x and y axis. Yeah, when we found our first, when sine part of this whole function is equal to 0, remember cot is equal to cosine divided sine, and we can get x is equal to 1 over 2, 0.5. And the next asymptote is exactly 1 period after the x equal to 2 asymptote. Therefore, it's going to be 0.2 minus 1 period or plus 1 period to get the other two asymptotes. This is why first step we calculate the period. And you will start to notice that after you get to the fifth step, you'll know the vertical shift is very important as well. So the step 1 and step 2, period and vertical shift is very important to draw the graph. Now I'm trying to find a midpoint. Between two asymptotes, there is midpoint. Midpoint for a cot function is usually on the x, but because there's a vertical shift, the y is equal to 1. Y is going to be 0 plus 1 equal to 1. So we'll find the midpoint between two vertical shifts on the graph. It's important to say on the graph. So I'm trying to draw two periods for this cot function. This is why I'm calculating two midpoints. And there are special points. I didn't write on the paper what are special points. Special points are those points between the midpoint and its closest asymptote. So you have two special points, which means two midpoints between the midpoint and the asymptotes. And those will be affected, their y value will be affected by amplitude. So if amplitude is 1, their y value, or there's no shift, their y value is -1 and +1. If amplitude is 1, there's no vertical shift, or there's a vertical shift and the amplitude is 1, you shift up 1, you're going to be 0 and 2. But this one is amplitude is 2 and also shift 1. So the larger special point is going to be 3. The smaller special point is going to be -1. But -1 is 2 units away from 1. And also 1 is 2 units from 3. So that's why we want to put special points on the graph. Once we're done, and the shape of a cot function, it would be much more accurate. So instead of using 1 point to draw the graph, we're going to use 3 points to draw the graph in each section between two asymptotes. Yeah. I'm doing some final calculation here to get the asymptote. not asymptote, the special points and its y value. And remember, special points for the same y value exactly has interval of a period. That's why I'm using period to calculate the special point before the positive special point. I mean, the left and right, two sections of this graph, two periods of this graph. So I use minus period to get those two special points. So step 6, I got 4 special points on the graph. Step 5, midpoint, I got 2 points on. Now all I do is it's increasing function. Again, the step 4 also helpful. It tells you it's increasing. And confirm it is increasing. And you know that -1 is 2 away from 1, which is a midpoint or original point, you call it, for each section. And 1 is 2 points away from 3. That's consistent with our amplitude. And now all I have to do is link all these 3 points in each section. And that's it. That's the graph of the cot function. Thank you. Method we use to draw the graph of a cot function also can be used to draw a tan function. So first step, period, second step, vertical shift, and the third step, get the amplitude, and the fourth step, vertical asymptotes, and 3 and the 4th steps can be switched. So once you get the vertical asymptotes, you calculate the other 2 asymptotes right here using period and the first asymptote. And you can get all this dotted line here. So you can separate the 2 period into 2 sections. Each section has a 1 period, and then you have a midpoint calculated between the asymptotes, 6 pi and 2 pi over 3, and then you calculate special points. And I made mistakes here, but I corrected it. It's x to the 24 7 pi, and then you calculate the next special points. I mean, talking about each section has 2 special points. So you need to calculate the next section. So once you calculate a section, but remember the step 3 already told us that this whole function is a decreasing function. So whatever you got for a bigger number, like 24, 13, that's as a 5. A smaller number in a section, the bigger number is 24, 19 pi. 19 pi over 24. That's a bigger number, but the y is a negative 1. Smaller number, the y is positive 5. That's why it's a decreasing function. And you find that the other 2 number, one is a negative. One is positive 24 pi, pi over 24. The other one is positive 7 pi over 24. That's in this section. Then you draw the graph based on that. And this is correct. We're using the same method we draw the cot function.